Welcome to the Smoke Status in Washington webinar, our WAVE webinar. This is Melissa Hanson, and this is a joint effort between Washington State University, the Washington State Wine Commission, the Washington Winegrowers. And I am going to take care of the housekeeping issues. So real quickly, your questions, you'll notice there's just the Q&A. Put your questions in the Q&A. Don't worry about a chat. Thomas will keep track of the questions. And we had several that came in ahead of time, and we will attempt to address those as well. And just again, I have to remind people this is being recorded. We will have a link available by tomorrow that we will share to all those who registered. And then I'm sure Winegrowers and the Wine Commission, we will share it in another email that goes out. It will be, I think right now it will be a YouTube link, but you have to have that link to watch it. So it will not be available to the general mass consumers. And with that, I have one slide to show. Whoops, whoa, I hit that too fast. Come on. I just want to remind you, as the research director for the Wine Commission, you know, the smoke exposure is just a perfect example of the importance and the return on investment that this industry receives from its research investment. So, you know, just real quickly, all of this started in 2016. WSU was the first university in the US to really start to develop a smoke research program. Where they could simulate and replicate smoke events. And in the last 4 to 5 years, we have directed about $365,000 towards smoke research. Wish I could say we have all the answers, but this is an extremely complicated subject. And just in the last 2 years, 2 to 3 years, Washington, Oregon, and California scientists are working together and sharing efforts, and they've kind of divvied up the work so that we can get way more done. Our industry investment helped leverage first a specialty crop block grant that Tom was able to secure in 2019. And then the team of the 3 universities, they applied for a planning grant that now will work itself into asking for about a $4 million research federal grant from the USDA for this next year. And then in addition to all of this, the task force, which Vicki will touch on next, was able to secure some USDA ARS funding. And $2 million looks like a lot of money, but by the time it gets to the universities and to USDA, it's not so much. But you know, we are the only state right now that has particle counters out in vineyards. This wouldn't happen if we didn't have an ongoing research program where we can, you know, quickly jump on major issues for the industry. So with that, I'm going to stop sharing, and Vicki is going to talk real quickly about the task force.
Thank you, Melissa. So hi, everybody. This is Vicki Charlo. I'm the executive director of the Washington Winegrowers Association. And I just wanted to share that much like what Melissa talked about in terms of us gathering together, not only for purpose, but also funding for things like research. You know, historically, the industry, not just in Washington State, but I think up and down the West Coast, we've done a really good job of rallying around quickly and thoughtfully around issues like pests and diseases or other issues that we've had descend on us. The challenge with this particular effort is that we don't see an eradication method in our future. So we've got an annual and pervasive issue for the state of Washington and Oregon and California that we don't see getting better anytime soon. So back in January of 2019, our then chair, Patrick Ron, sent an email out to his counterparts in Oregon and California and said, you know, there's much we don't know about smoke, and all 3 states have been impacted and impacted hugely, consistently, and it's getting worse by year. So how about if we get together and establish a West Coast smoke exposure task force, with the idea being that we want to gather the questions we have and what we do know, but also what we don't know, and start to focus on getting funding and getting answers to what we don't know. And Patrick had put together an email that was pretty clear, I think, and succinct, where he talked about wanting to address smoke exposure and smoke in general in a way that was uniform, consistent, fair, and equitable, and really easy to understand, because it's a complicated subject, as we find out now with the more research we do. So he had a list of things we wanted to look into, definitions and standards of what taint was. And you can tell in our conversations, we rarely use that word because grapes can be exposed, not necessarily tainted. So we wanted to talk about contract language that were established standards and were best practice based, crop insurance access, more information about it and what it does and doesn't cover, and how we can really expand that, outreach to growers and wineries up and down the West Coast, and then disaster assistance, which we are particularly focused on this year because of the severity of the issues, not only in Washington, but certainly in California and in Oregon. So, and Melissa's already hit on the research side. So the task force is separated really into three big buckets of work, if you will. One is research. And we've gone a long way very quickly for getting funding, like Melissa said, matching in our case in Washington State, but also pushing on ARS, the Ag Research Service with the USDA, to have them help our researchers in Washington, like Tom Collins, in Oregon and California, so that we can work jointly and understand some of these issues and focus money with particular skill sets. The other bucket is on contracts, and the third bucket is on crop insurance. So the task force continues to meet. There's two documents that are already out that I hope everyone has access to. One is on microfermentation protocols. The other one is on grape sampling protocols. Very soon you'll have a frequently asked questions document. And then after that, you'll be seeing a roadmap that'll talk about the grape cycle, the growth cycle, and issues that should be resolved as you go through that growth cycle if you in fact experience smoke exposure. So things that you should be doing both as a winery and as a grower in that process as the grapes grow throughout the year. So just wanted to give you a quick update on what we're doing in terms of industry organizations up and down the West Coast. And with that, I have the pleasure of introducing Thomas Hennett-Kling, who's the Director of Viticulture and Enology for the WSU Wine Science Center and Professor of Enology based at the Tri-Cities campus in Richland. Thomas, take it away.
Thank you. Well, hello and welcome. I just wanted to start with a short retrospective. In about 2013-14, we started asking the question that should we be addressing the issue of smoke exposure in our vineyards, and some of the taint issues that we saw then, mostly sporadically. Initially, that was met with some skepticism. We were all hoping it would go away. But as Melissa Hansen said, in 2016, we got the first funded project going, and that was lucky that in 15, we actually had hired Tom Collins, who already brought some experience in smoke taint research with him. So we were off and running. And as you've heard just now from Vicki and Melissa, we've got a great research and outreach program already established. I see this whole program to keep growing in its research effort and in education of the industry, providing solutions. And I think in the end, there has to be a West Coast management system set up that monitors smoke events, has a system of determining which ones are serious, which could cause a problem for grape growers in the various areas, and how we respond to that. So I think it's going to be a yearly monitoring managing program that hopefully we can do in this tri-state collaboration. I'm very encouraging that we'll get there soon because we have this tremendous support from our industry here in Washington, but also from the industries in Oregon and California. And we're really building a research capacity here in Washington, and now also in our partner institutes at Oregon State, UC Davis, and USDA ARS as well. So that infrastructure all will come together to help us find solutions to the problem and manage it every year. Thank you. With that, I'd like to introduce Dr. Tom Collins. He's the lead researcher on smoke taint research and outreach for us here at Washington State University. I mentioned Tom came to us in 2015 after several years of research lead in the wine industry, but he's got a broad background in grape growing and winemaking in the US, and he's an analytical chemist. And Tom will tell us what he's learned so far and where he's heading. Thank you, Tom.
Great. Thank you, Thomas, and thanks for everybody that has been involved in getting this put together so quickly. I think the idea to have this session probably really started just towards the end of last week and really got the ball rolling on Monday. So can everybody see the presentation? Is it up there?
Yes, Tom, just put it in presentation mode.
All right, how's that? So as I was saying, this really just came together in the last 2 or 3 days as it became clear that the smoke we were seeing towards the end of that last week, following the smoke event over Labor Day weekend, was continuing, and it was really time to get some information out to the industry. And so we've put this together, and there are 2 or 3 things that we'd really like to work through this afternoon, and we'll have time for questions at the end. We've built in time to this session for that. But I want to start with just some of the things that we're doing in terms of assessing risk from smoke exposure, and in particular talking about air quality monitoring, what's out there in terms of tools for looking at that, and then specifically the things that we're doing. So Melissa mentioned that we've got particle counters out in the vineyards, and we'll talk about what all of that is for and what we hope to get from that. And then we'll talk a little bit about testing for smoke exposure, in particular a focus on the micro fermentations or bucket fermentations, because there have been a number of questions in the last couple of days and throughout this event about the need, or would it be helpful to wash your fruit? We'll talk about that, and then a little bit about chemical analysis. So I want to, let's see, there we go. So I want to start by talking about the air quality index. I think probably most of you in the last week have become very familiar with the concept of an air quality index. So there are a number of websites that you can go to. This one is from the Washington State Department of Ecology, and it's their website for their air monitoring network. And as you can see, and you've seen this, you get the map of Washington State with the round dots that can be different colors. They have tended to be mostly red and purple recently, but they have also sometimes been yellow and green. So we'll talk a little bit about what that's about and what that's actually measuring and why it's out there and how it relates to smoke exposure in the vineyard. So we've all seen these. There's been a lot of information in the news about how unhealthy the air is. And the air quality index is a system that really was developed to focus on some major pollutants that can be in the air. So their particulate matter is one of the things that the air quality index is built on, but it also looks at things like ozone, NO2, sulfur dioxide, carbon monoxide. So there's a handful of things that they monitor. And what we typically see posted is the PM 2.5, and that's what's shown here for the most part in the background is the PM 2.5 based air quality index. And the air quality index is really a scale from 0 to 500 that has different groupings: good, moderate, and as you go from green and yellow to the red based colors, you get into increasingly unhealthy concentrations of these particulate matters. In particular, this is measuring PM 2.5. So PM 2.5 refers to particles that are of a certain size, in this case, 2.5 microns and smaller. And the other one that's frequently measured is PM10. And PM10 is really more a measure of dust. So that's bigger particles. And the real concern about PM 2.5 is that it has a respiratory effect. It can enter directly into your lungs. The particles are small enough that they're not captured by your sinuses and things like that as you breathe the air in. And so the real concern is 2.5 can get directly into your lungs and create problems. And so that's why it's a measure that they look at, and it's specifically tied to the human health impacts that size particle can have. Yep. So we look at something a little bit different when we're looking at smoke. And so in our research trials, we have these portable particle monitors. They're from a company called TSI. These are portable. They have a battery pack that allows them to run for about 24 hours at a time before they need to be charged. They can also be plugged in. But these monitors measure, or the way we have them set up, measure PM 1.0. So this is particles that are less than 1 micron in diameter. And the reason we're interested in those is that the size distribution for smoke particles, they're the things that we're most concerned about for their impact on grape quality as opposed to human health, range from about less than 0.3 microns, so a third or smaller than PM1, up to 2.5. A lot of the soot particles end up being at the higher end of this scale and up closer to 2.5. So if we want to focus on smoke, we really find that looking at PM1 is a good way to do that. Now, if you're measuring PM 2.5, that kind of a monitor, and we can do that with these instruments. PM 2.5 measures things that are 2.5 microns in size and smaller. So that would include all of the smoke particles, but it also includes some things that are not directly related to smoke, or at least not directly related to the part of smoke that we think is problematic for grapevines. And so by going to PM1, we get into the heart of the size distribution that's related to smoke as it impacts grapes, and cut some of these other things out that are not as closely related. And so we think for our purposes, and we've seen this over the last week or so, the use of PM1, I think, gives a slightly different response than using 2.5 or looking at the AQI index, because it's more specific for the things that we're most interested in. They don't always follow each other closely. So we have, as I said, we've used these monitors in our vineyard research trials. So when we do a deliberate smoking where we're using our hoop houses and deliberately smoking grapevines for trial purposes, this is the tool that we use for monitoring the density of the smoke that we're applying. And we've been measuring initially we were measuring PM 2.5. When they made an improved model of this, we went to PM1. And so we had, for the most part, finished our deliberate smoke exposures for this season on August 12th, but we still had the monitors because there was a possibility we would do another smoke exposure after school started. So we still had them, and based on some information that we had from the WSU Laboratory for Atmospheric Research has a modeling tool that can predict, or that can be used to predict when there might be a smoke event. So we've been following that. And around the 23rd, 24th of August, that model was predicting that we could see smoke coming into the area from Oregon. And so we put together quickly just we saw it as an opportunity to sort of see what an actual event looks like and try to get the monitors out there before it started so we could follow how that event unfolded. And so we put 5 of these monitors in vineyards in different areas, mostly in the eastern end of the Yakima Valley. We were concerned because the smoke was coming north from Oregon. And we put them out there, and the smoke event actually did happen. We saw the plumes of smoke coming in from Oregon, but at least at that time, the plumes were going by not at ground level, but several thousand feet up in the air. So you could look up in the sky and see the dark brown smoke plumes going overhead, but it wasn't recording on our particle counters on the ground. So, but a couple days later, the Evans Canyon fire got started, the big fire that burned basically between Yakima and Ellensburg. And so there was some interest in putting some additional particle counters out at that end of the valley. So we have three more monitors that are placed further out towards the western end of the Yakima Valley. So we've had, since the 3rd of September, we've had 8 monitors, which is the number that we had from our trials, placed at different places up and down the Yakima Valley, and then one up towards Mattawa, and then one down near Patterson. So we've got a pretty good, at least for this area, a pretty good distribution of these counters geographically to look at how things might change from one end of the valley to the next, whether there are differences in the intensity of the smoke that we're measuring, whether we see differences in timing. So it gives us an opportunity to really look at the distribution of smoke in this area during an actual event. And so we've had them out there since the 3rd of September. And as I think everyone knows, on Labor Day, we had some pretty significant winds and a lot of smoke and dust as well. And so what I'll show you now is what this looks like, what the PM1 monitors tell us during one of these events. And so this is for one of the vineyards that we are working with in the Red Mountain, Benton City area. I'm being careful not to divulge who we're working with, just to keep this confidential. But so we have a couple of different vineyards in this area that we're working with, and this looks at the period from midnight on Monday morning, so the beginning of Labor Day through the end of Labor Day. And you can see about, at this particular vineyard, about a little after 3 in the morning, the smoke started to come in. And in this event, peaked at just below 1 milligram per cubic meter, and then started to come back down. And by 7, we were back almost to the starting point, but then there was a second wave of smoke that got up to about 1.4. And then right around 11:30 or noon, depending on where you're at, there was a very sharp drop off in PM1. And a little bit, a couple of times later in the day, but from noon on, even though the air quality to look at it was still very poor, if you went outside in the afternoon on Monday, the air quality looked terrible, but you didn't smell smoke anymore. And the AQI numbers were still recording fairly high levels in the afternoon. But for our purposes, PM1, the smoke components that we're concerned about, really were no longer at any level to speak of after about noon at this particular vineyard. And if we look at one of the other vineyards that we work with in the same area, they had a very similar pattern. It starts around 3 in the morning. The first peak reached about 1 milligram per cubic meter and then dropped off. Then you get a little breathing space and then a second event. And again, a very sharply delineated, this is the end of PM1 in this event. Even though the air quality continued to be bad, the smoke aroma in the air was not there anymore. And if we look at some other sites, this is the WSU vineyard, the Rosa Vineyard north of Prosser. Started about the same time. There was more smoke or more PM1, higher PM1 levels in that first event that starts at 3. We don't get a complete return to the baseline before the second one starts. But again, at the end of it, it's a pretty sharp drop off and back to very low PM1 after about 12:30 or 1 o'clock at this site. So just by going 10 or 12 miles further west to the kind of the northwest of the first two vineyards, we get a different amount of smoke and a bigger contribution from that first wave of smoke, if you will. We can look at some other sites. This is a vineyard out at the far end of or towards the west end of the Yakima Valley. So you'll remember from the previous slides, the event started around 3 in the morning in the Tri-Cities area, Benton City and Prosser, but it didn't start until later and never really didn't really get going until a little later in the afternoon. But you still had this double peak. The intensity is lower. We peaked out around 1.4 or 1.5 in the first 3 vineyards we looked at, but at the west end of the valley, we were only up about 0.7 or 0.8. So a little bit different event, lower intensity and later timing, just by going 50 miles further up the valley. Yeah, that's all right. Okay, so what we looked at prior to this was just the Labor Day smoke event. This is now looking at, again, one of the vineyards in the Benton City area. So this part of the peak or this part of the trace is Labor Day. This is the period from the 3rd of September through earlier today. So so it's a different time scale, so everything's compressed. This is that Labor Day event. This is basically the beginning of the smoke event that we're currently in, starting on Friday morning. And we see pretty quickly a rise that takes us up to, in this case, about 2.5, 2.6 milligrams per cubic meter by 10 o'clock or so at night on Friday night. And since then, it's been a general decrease. And by this morning or early afternoon, we were down to around 0.5 milligrams per cubic meter at this site. And so we do see this spike, and then it comes back down, and then just a general downwards trend over the course of the week. So if we look just at the period from the onset of this event through today, the average PM 1.0 for this site from Friday morning until now is 1.27 milligrams per cubic meter. Keep that number in mind. We'll come back to it in a minute. So just a little bit over 1.25. If we again go back to the vineyard on the west end of the valley, we see here's the Labor Day event. They had a previous spike back on the 3rd and 4th that was from the Evans Canyon fire, which was why we put this out there in the first place. So they had a little spike there. There's the Labor Day event. They've had a little bit of smoke during the week leading up to the bigger event that starts on Friday. Again, there's kind of an uptick, and then since Monday or so, it's been generally coming down. The peak is not quite as high as it was at the previous vineyard. And there it is. The average for this period from the onset, right in around here through the earlier this afternoon, was 1.02. So a little bit lower than what we see at this end of the valley, a little bit lower at the other end of the valley. We have other sites in between. I just haven't had a chance this week to be able to go out and collect that data. That'll be something for tomorrow. So 1.27, 1.02 were the averages for those two sites during this event. And the reason I wanted you to remember that is this is a PM1 trace from one of our deliberate smoke exposures this summer. This was from our trial that was this 28th and 29th of July. And our average value over the 36 hours that we did this test was 4.78. And we typically aim to be somewhere between 5 and 10. And we see when we do this, the overall average is 4.78, but we often have spikes that go up as high as 10 or 20, in some cases higher. And we aim to be in that area because we think that will generally result in wines, in fruit that's been affected and wines that have been affected, because we need those kinds of wines to be able to do mitigation work on and things like that. So the other thing that's important to understand from this is that we're also looking in this case at fresh smoke that we're generating right at the front of the hoop house. So this is, we burn these hardwood pellets, or they basically smolder, and that freshly generated smoke is then delivered into the house directly to the fruiting zone so that we're sure that we see the effect we're looking for. So the levels, the average levels that we've seen in the 2 vineyards we talked about are 20% of this number. And in the instance of the smoke that we're experiencing now, this is not freshly generated smoke that has just been produced from a fire on the other side of the ridge and carried directly into the vineyard. This is smoke that has traveled some distance. And there's a general consensus that as smoke travels, it loses its potency, its ability to create these off aromas and flavors we're looking for. So fresh smoke is generally considered to be more likely to have a negative outcome than smoke that has traveled for some distance. So one of the things I think that's important to understand from this, looking at what we're actually seeing during this event, is we're getting a good sense of what the actual levels of smoke-related compounds, or not compounds, but particles are during an actual event that actually looks like it's a fairly severe event. And there's certainly been a lot of press about it because of the high AQI index numbers. But when we're looking at something different, we get a better, clearer picture of what it really is. And yes, there's some smoke exposure here, but compared to what we're doing during our trials, it's still not, the exposures are not that high, and there's a difference in the quality of the smoke. But I think having the opportunity to have these particle counters out there has given us this insight, and also suggests that one of the things we should be considering as an industry is getting some of these PM1 particle counters out so that we can do this kind of monitoring on a routine basis. In this case, we're able to do it because we had the counters already from the research program that we spent most of the summer working on. But I think the insight it gives us and the information it provides about what's happening during an actual event and how the smoke is distributed and what the actual intensities are in different locations and for how long, I think will be really valuable for us in terms of understanding going forward what kinds of events are more likely or less likely to cause us reason for concern. So I think having these tools available has provided a lot of insight and really suggests the direction we need to be heading in terms of being better prepared for risk assessment when we're going forward. So one of the things I want to emphasize is what we've done so far is monitor this. We have a good idea of how much particulate matter of the PM1 size, that small size that we're concerned about, was in different locations. What we're not able to do at this point is really directly translate that into what's the outcome. What is it going to look like? Now that's something we will use this as a starting point because we have a lot of information about where the smoke came from. We can work backwards from here to where the smoke started. We know where many of the fires are that would have contributed to the smoke. We know something about the fuel source. So we have some information that can help us make better sense of this because we have a lot of information about where the smoke came from and we know how much of it was in our vineyards. To translate it into what the actual impact is, we need to get beyond things like the information we need concerning the fire, the timing of exposure, fuel source, et cetera. Those are things that make it difficult to go directly from a particulate count to an impact. But now we have information about what happened in specific vineyards. We can get fruit from those vineyards and do fermentations. We can do the bucket fermentations and then do the chemical and sensory analysis of the wines that come from that. And perhaps look at what happens in production scale fermentations from that fruit as well, so that we can now start to say, we know something about how much smoke, what the smoke density was in the vineyard. We have information about the fires, the fuel source, the temperature, things like that. And we can tie that to specific outcomes from fruit that was affected in a way that we know how much was there. And so that's the next step in this process, is as this event winds down, we'll get fruit from the vineyards that we're cooperating with and do small scale and perhaps larger scale fermentations as well, so that we can tie those two things together. And so at this point, I want to transition into talking about bucket fermentations. That's one of the major things on the objective list for today. And I'll start just by going back and reviewing some work that we did last year, looking at bucket fermentations. And so there was a fire that affected some vineyards near Mattawa last summer in July. The fire burned down the ridge and into the top of some of the vineyards that were affected. The fruit from those vineyards, some of the fruit was donated to us last year to do some work trying to evaluate bucket fermentations and how they compare to larger scale fermentations. And in this case, we looked at 4 different cultivars because they were present in at least 2 different blocks within that vineyard. So we had Cabernet, Petit Verdot, Grenache, and Syrah. And the way that particular vineyard was laid out, you had blocks that were higher on the hill and closer to the fire, and blocks that were further down the hill and maybe a little bit lower smoke exposure. And so we had high and low blocks for each variety. And we did bucket fermentations in triplicate, and then we did bin fermentations in duplicate for each of these. So we have a total of 8 different lots, high and low for each variety. And what I'll show now is just guaiacol content. We'll look at 2 or 3 different smoke-related compounds. This is guaiacol, one of the primary marker at the moment for smoke exposure. And so we have across from left to right several different pairs of bars. In the blue on the left, we have the Cabernet low and the Cabernet high. And on the left in each of these pairs is the concentration from the bucket fermentation. On the right is the concentration from the bin. And so as we go from left to right, we have Cab low and high, we have Grenache low and Grenache high, Petit Verdot low and Petit Verdot high, Syrah and Syrah low and high. And in each pair, it's the bin on the right and the bucket on the left. And so I think you can see there's pretty good correlation between the results that we get from the bucket fermentations and the results that we get from the larger macro bin scale fermentation. And generally, at least for guaiacol, there's a little bit better extraction from the bin fermentation, the larger scale fermentation, than there was in the bucket. So in most cases, it's a little bit higher concentration in the bin than what we see in the bucket. We can look at 4-methyl guaiacol and we see more or less the same outcome, that where we have low concentrations, we have low in the bucket, low in the bin, higher in the bucket, higher in the bin. They generally pair very well, and the buckets look like a good way to estimate what you'll see in the resulting larger scale fermentation. Interesting, so when you look at guaiacol, 4-methyl guaiacol, and a few of the other volatile phenols, generally speaking, Petit Verdot, in this case, had the highest levels, and then Syrah. The 2 Cabernet blocks were not right. The high block for Cab was not in the top, it was down a little bit. So generally Cab values were a little bit lower than for the other varieties. But for guaiacol, 4-methyl guaiacol, 4-ethyl guaiacol, generally speaking, Petit Verdot was the highest. When we look at cresols, so that's not part of the markers that we look at in a normal panel, but in an extended panel, cresol would be included. It looks a little different. the highest levels of cresol are actually in Grenache. So Grenache for guaiacol and 4-methyl guaiacol was kind of in the middle, but for cresols, Grenache is higher. And actually the cab values are higher as well relative to Petit Verdot and Syrah. So one of the key things from this is that different varieties behave somewhat differently in terms of what compounds they take up or what compounds get glycosylated. So the behavior is not quite the same. You can't necessarily say, we know guaiacol, we know 4-methyl guaiacol, we understand that the others are going to follow, because it's not necessarily the case in every variety. It's clear that Grenache is behaving differently than Petit Verdot or Syrah with regards to cresol. And this is orthocresol, metacresol behaves the same way. So I think it will become increasingly important to get cresol numbers in addition to guaiacol and 4-methyl guaiacol. But from the point of view of our bucket fermentation is good at predicting what we'll see in the bins or in tanks, again, the results here track pretty well. So we think this is a good validation of the use of buckets for predicting what the outcome might be in a bin or a larger scale fermentation. So the smoke taint or smoke exposure task force spent a fair amount of time over the past few months talking about tools for how we can determine whether we have an issue or not. And the bucket fermentation is one that has been around for a while, and we think is a good tool, and one that we need to use routinely for a few reasons. One of them, as we're currently experiencing, is if you have a major smoke event that is impacting a wide area of vineyard and winery production, it's likely that the available lab capacity for doing analytical work, for doing grape berry analysis, for example, can be severely challenged. And there are some opportunities for increased lab capacity, and those are being pursued. But we're still in a situation where analytical results from a lab may not be available, and in some cases are not likely to be available when you need them to make picking decisions. And so bucket fermentations may be, in many cases, the best tool, particularly during a larger smoke event, to be able to make assessments of what your risk is. We also think it's important to recognize that the guidance that's available about chemical data and what it means in terms of your risk for exposure is based on experience with a range of wines. And in many cases, it's based primarily on Cabernet, because that's a major variety. And so a lot of the experience people have with making estimations from chemical results to what the risk is for smoke taint are based on what they've seen primarily in Cabernet. And as I just showed you, not every variety behaves in the same way. And so cresol may be important for some varieties. And so it's important to recognize that that guidance that's available about chemical analysis is based on wines that may or may not be similar to your wines, your matrix, the smoke that you've experienced. Doing the bucket fermentation and sensory evaluation of that gives you direct information about your specific wine and what the impact of the exposure was on your wine. Now, chemical data is good to back that up, and over time we will get better at understanding all of the nuances of chemical data to smoke impacts that we see. But sensory evaluation of these bucket fermentations is a really good tool for getting information directly about your own wines. You need to be able to develop your own sense of what these results look like and how that works for your wines, and what levels of effect might be something you can work with versus something that you maybe don't want to get into. So we think bucket fermentations are a great tool for getting through this, and even if the lab analysis is available, we think it still plays a role because it's very specifically about your situation. So the Smoke Exposure Task Force has put together a common protocol for bucket fermentations. I think that's been distributed already, right? That went out last week. So you should have seen that either in an email from the Wine Commission or from Washington Wine Growers. If you haven't, let us know and we'll get it to you. And this protocol really lays out the process, the steps in the process for doing bucket fermentations, including things like the amount of fruit you need, how to prepare the fruit, nutrients, yeast, enzymes, the various things that can be added or that need to be added to your bucket fermentation to get the outcome we're looking for. And one of the key things to recognize about this protocol, and I think many of you may have seen it already, and we've had some feedback about it, is this protocol is really designed to help you get to the worst case scenario. We want to make sure that you don't, as much as possible, have a false negative where you do the analysis, do the bucket fermentation, smell it, it seems fine. We want to do things that you wouldn't necessarily do in your normal wine production, the things that we know are related to getting these compounds out of the skin so they're there for you to be able to smell and taste them. It's sort of set up to give you the worst case scenario. And it was designed to be relatively approachable for growers and wineries to use. We have a standardized protocol that should be consistent across the board. The sensory evaluation means you don't have to have the instruments to be able to do the chemical analysis. You can do a sensory smell and taste and understand something about what the outcome is for your wine. And these protocols can always be modified to reflect your actual winemaking practices. It was designed specifically to really test the fruit and make sure that if there was going to be a problem, you would be aware of it. But you can always dial back the protocol and making something that's more similar to what you would actually be doing and see what the outcome is there as well. And so this protocol includes, as I said, steps that are going to be different from what you normally do. For example, the protocol suggests doing fermentation of white grapes with the skins, just like a red fermentation, because we know that the compounds we're interested in are present in the skins. And so our normal winemaking practice of just fermenting the juice will minimize the extraction, but we really would like to know, is it in the fruit or not? And by fermenting with the skins, there's a better chance that if it's there, it'll be expressed. Similarly, the protocol calls for the use of pectinase enzymes. And again, that's to facilitate breakdown of the skins and release of these compounds so that you're going to see them if they're there. And then there's some other things like adjusting pH to a consistent range and adjusting some other adjustments to make it more consistent from one lot to the next. So again, some of these are designed to make sure that we extract whatever's there. Some of them are steps that make the evaluation of the wines more straightforward. So we know that both alcohol and acidity can affect the sensory perception of many wine aromas and flavors, including, we think, some of these smoke-related ones. So we want to have a consistent pH, consistent alcohol levels, so that you can more readily compare one to the next and have an easier sense of what wines might have a problem, what wines have a small problem, what wines have a big problem. And it's because of the amount of material that's there, not because of some other factor in the wine that makes it more perceptible in one versus the other, if that makes sense. So I'm not going to go through the whole protocol again and reinvent the wheel. Anita Oberhoster at Davis has done a really nice job of putting together a step-by-step video that walks you through all the steps. And this was supposed to be pre-work. You were supposed to have viewed this video before we came to the session today, but I know how it goes when I ask my students to look at videos or do readings prior to class. So it's out there, about 30 minutes long, and it's a very clear step-by-step what you do to do these fermentations according to the protocol. And it includes information on the materials that you need. It includes information on the sensory evaluation of the resulting wines. So the video is well done. It gives you some really good tips on making stock solutions to make the measurement of the materials you're going to add easier to do. So it's a good video and worth spending some time looking at it to understand better how this protocol works. So there were some good tips on making stock solutions. And then the other thing was about modifying this protocol. It may make sense The protocol specifically says do white fermentations with the skins, but you may want to do one version with the skins and one version where you just do the juice in your normal protocol, just to see if there's a difference in how what you might perceive in the two different practices. There are some supplies you need to have to be able to do these bucket fermentations. I think most of what you need is probably available in this area at Central Industrial Supply in Richland. They carry yeast and nutrients. You may be able to get them from the winery you're working with. If you're part of a winemaking operation already, you'll have most of these things available in your lab or in the cellar. If you're doing this and you haven't done these things before, there are some home winemaking shops, physical shops or online shops where you can get some of the materials as well. And I would say there's a couple things if you're doing this for the first time that you need to be cautious with. The protocol includes using a 2% SO2 or sulfur dioxide solution. You need to be a little careful with SO2 solutions. Even at 2%, it will get your attention if you stick your nose in the bottle. So just be careful with it. The protocol suggests using Clinitest tablets for testing to see that the fermentation is finished, so looking at residual sugar. If you choose to do that, you need to be careful with Clinitest tablets because the reaction that's involved when that test is going on generates a lot of heat, and the test tube or other beaker or whatever you're doing it in can get pretty hot. And then this is just an always kind of thing. If you're working with chemical solutions, you need to make sure they're labeled so you know which is which, because after a while, all those clear solutions look exactly the same. And you don't want to have to figure out which one is SO2 by sticking your nose in it, because we already talked about that. So, and then one other development with bucket fermentations. These have typically been done in 5-gallon buckets like you would get from Home Depot or Ace Hardware or other supply places. But there's a newer version that's being developed that looks at doing these on a smaller scale. So it's been coined nano fermentations or mason jar fermentations. We have one set up at the Wine Science Center. Right now we've got about 11 fermentations going. The idea is very similar to bucket fermentations, but it's on a smaller scale. So if you're going to do this on a smaller scale, you need to be very aware of sampling protocols, because you're really going to need to make sure that your sampling in the vineyard really reflects what's going on in that vineyard well, because we're working now with smaller volumes of fruit than we were even in bucket fermentations. And so typically now we're going to try this in 1.5 or 1 pint mason jars with the metal lids just on loosely to keep the fruit flies out and to let the CO2 go. It was originally developed to do in a lab water bath, but those have limited capacity generally. So we've gone to a plastic tub. This is actually the kind of storage container that slips under your bed to put wrapping paper or whatever out of the way when you're not using it. So it's about 6 or 7 inches deep, 20 inches by about 30 inches long. So this one will hold 36 pint-sized mason jars. And then this black part here is a sous vide circulator, so a sous vide machine. And it does two things. One is it circulates, got a little pump that circulates water in the bath. And then it's got a heater. So it's set to 80 degrees Fahrenheit, and it circulates the water and keeps that water bath at a consistent 80 degrees. Now, one of the big advantages of going to this kind of smaller scale fermentation in this setup is that you can get the fermentations done more quickly. So typically by day 3, this scale of fermentation is complete. And so what we're planning to do with this, we've got some trial ones going now. We started yesterday. When we get to the point that we're doing bucket fermentations to go with the particle counter data, we're going to do standard bucket fermentations using the normal protocol. And then we're going to match that with same fruit in the smaller scale fermentation, so we can see, are these results consistent with the results we get from the bigger buckets? we've already done some work to show that the bigger scale buckets are consistent with what we see in larger scale fermentations. So that's bucket fermentations. The next thing we'll touch on briefly is washing grapes. So this question has come up, and I think there are two different versions of this question. One is washing grapes to remove the smoke taint compounds. The second is the idea of washing the fruit to remove ash. So for most of the past 5 years, the first question has come up, and the general answer is washing the fruit to remove these compounds generally doesn't do anything, because the grape very, very quickly absorbs these compounds, takes them into the berry, and they're inside the skin cells, and you're not going to be able to wash them off with a pressure washer or an air blast spray or anything like that. So washing specifically to remove these compounds after a smoke exposure is not an effective approach. The second question has come up numerous times this year, and I think it's because there's something different about maybe the temperature of the fires this year compared to prior years. There seems to be more ash questions coming up. Ash seems to be present in some vineyards, at least from some of these fires. And so the literature is not really clear, kind of contradictory results. There was a study 20 years ago now almost, where they pulled leaves and washed the ash, and that seemed to reduce the impact. They took the leaves off the canopy first, then sprayed the ash away, and that helped. There was another study that they didn't remove the leaves, and washing the ash in that case didn't seem to help and may have made things a little worse. So the outcome is not clear based on what's in the literature. When this question first came up in August, we went through the process of generating some ash and then doing an analysis to see what's in the ash. And we did find that fresh ash does contain some volatile phenols, including glycol, 4-ethylphenol. There were 2 or 3 syringol showed up in some of the ash. So that's fresh ash. We generate it, take it into the lab, do the analysis. We also took some of that ash and held it for 24 hours, just aged it, put it in clear vials and left it in the sun for 24 hours and then ran it again. And in that case, we found a reduction in the amount of guaiacol and other volatile phenols in that ash. So it does appear that, much like smoke itself, ash, there's some aging that happens in ash that, at least in this first pass study, looks like there's some reduction in guaiacol content and other volatile phenols as a result of that aging process. And we don't know exactly what's going on there yet, only that in this first look, we see fresh ash contains more than ash. Even after 24 hours, the level has gone down in the ash. And then the last thing I want to talk about before we go to questions is there has been a number of questions about labs and what they do. So I think most people are familiar with ETS in St. Helena. That's been the standard lab that people have been going to. Before this, so earlier this summer, they announced that they would be doing an extended volatile panel that would include guaiacol, 4-methylguaiacol, cresol, syringol. So it was a larger set of compounds. But they also said at the time, if we have a major smoke event, we may not be able to support that, and we may have to go back to guaiacol and 4-methylguaiacol. They also said that they could, in addition to doing the volatile compounds, they could do glycosides as well, the set of 6 or so that seem to be of interest. But again, that analysis takes a lot of time and a lot of effort. And in the case of a major event, they wouldn't necessarily be able to support that. AWRI has a commercial lab. So in Adelaide, in Australia, they can normally do the extended volatile panel and the glycosides. When things begin to back up at ETS, AWRI was one of the primary alternate labs. And so people started sending things there. I don't know whether they're experiencing any backup or not. and whether they've made any changes to the analysis they're doing. But under normal conditions, they would be capable of doing the extended volatile panel and the glycosides as well. There's a lab in British Columbia in Kelowna, Super R&D, and they also can do the extended volatile panel and the glycosides as well. And again, when things started to back up at ETS, they became an alternate lab and people began to send samples there as well. So I'm not sure, the last time I talked to somebody who had used them, they were still taking samples and still doing the normal analysis that they were doing ahead, but that was a few days ago. So they may still be doing that or not. I haven't talked to anybody that's used them recently. And then in the past day or so, we've also heard from another lab. This case, it's IEH, Laboratories and Consulting, which is a big lab company that does a lot of work in the food industry generally. So they do a lot of analysis in the meat industry, in the grain industry. They haven't done much to date in the wine industry, but they are up and running to do guaiacol and 4-methyl guaiacol at their lab in Seattle. And they're available, ready to take samples. And so I've got a picture of their flyer here. I think we can get that posted. That gives the information about how to contact them. It's specifically their lab in Seattle. They do have other labs in Richland and in Yakima, but those labs are not equipped to do this analysis. The only lab in Washington that can do this is their Seattle facility. And I think we're good now. So we have some time for questions. I think it's only just 5 o'clock. So we can start on questions and see where we go.
Great. Thank you very much, Tom, for all this information.
I'll unshare my screen.
So we'll go right into this questions. I'll start with the questions that were submitted just prior to this seminar this afternoon. This came from Jonathan Edelman. Do you have any data on the vineyard, on the impact of smoke particulates on the surface of grapes resulting from extended smoke exposure in the last 7 to 14 days in Eastern Washington? I think you addressed that, showing that you have all the smoke data, right?
Yep, I think I showed the information that we have about what is happening in different locations, at least within the Yakima Valley over the last week or so. Well, since the 3rd of September.
And the plan is to collect fruit from these sites and do the bucket and larger fermentations, but yeah. So that information will be helpful next year. We regret that we don't have that information available right now.
Yeah, and the particle counters are still in place. We're still recording PM1 data, and we will through at least the end of this current smoke event. And then we'll, once it's ended, then we'll get the fruit and start to really work on making that connection between what we see in particle data and what the sensory and chemical outcome was in the fruit that was exposed.
Yeah, and then Jonathan reports that they notice consistent toasted oak, toasted coffee character in the fruit that they have done the microferments on. Thank you for that. Tom, to clarify, when you say sensory evaluation, so you smell and you taste these samples, correct?
Sensory evaluation of the bucket fermentations would be both aroma, so smelling it, and then tasting it as well. And the reason that you would do both is some of the affected wines may not be overtly affected when you smell them, but because these compounds are present both as the free guaiacol, syringol, et cetera, and glycosides that have had a sugar attached, you sometimes, even though the wine may smell fine, you'll get an aftertaste, a smoky, ashy aftertaste that comes from breakdown of that glycoside from enzymes that are in our saliva. And those work on that glycoside while we're tasting it. And that gives you a smoky, or can give you a smoky aftertaste, even in a wine that doesn't necessarily smell affected.
So the tasting is very important to
Yeah.
confirm. Thanks. Next question came from Foolhardy Vintners. I think we answered the question about washing or spraying down the fruit. Then the next one was from Christopher. That was also washing grapes. As the smoke clears, this came from Glenn Ward. After the smoke clears, it dissipates, can speed sprayers of water go through the vineyard, rinse off? That's the same question. Washing the fruit in the vineyard does not seem to have a significant impact, correct?
Well, so it won't be effective at all on removing or reducing levels of compounds that are already been absorbed. And that happens pretty quickly. The need to do it to remove ash is not, it's not clear. If you have really heavy ash, one of the big concerns is if you go through with a sprayer, you may end up forcing the ash further into the cluster, particularly on tighter clustered varieties. If you're using an air blast or something, you may get it off the fruit temporarily, and then as it settles back down, it's right back where you're right back where you started.
Kevin Cedergreen asks, what is the minimum time exposure for grapes to be affected by smoke? And also the distance. You gave some numbers, Tom, about the 1 micron particle and the length of exposure. Can you already guess how much exposure at what particle numbers?
Well, no. At this point, we don't know, for example, from this smoke exposure, what the outcome is going to be. We have good information now because of these particle counters on the amount of particulate matter that's related to smoke that was experienced in those vineyards. But the other part of the question we don't understand, which is what the composition of that smoke particle was. We don't know. I mean, we have some idea about how far it's traveled. We don't necessarily know the composition of the fresh smoke in this case and how it might have changed while it was traveling, or even more basically, what the composition is when it arrives here. So at this point, we don't have a good answer for what the impact of this exposure is going to be, if any, because we don't really understand essentially what the quality of this smoke was when it arrived in our vineyards.
But from your experiments at the vineyard in Mattawa, where you showed the smoke exposure for fruit that was closest to the fire line and then some that was further down, that distance wasn't very large. How many yards?
No, I mean, it was in the end. So what we think we know is that when you have fresh smoke that's generated close at hand, and for example, a fire that burns up to the edge of the vineyard, that smoke has generally speaking, the greatest potential for creating off aromas and flavors. We also know from that experience last year with the fire in Mattawa that you don't have to get very far away from the edge of the fire before you start to see a reduction in the impact. What we don't have to go with that distance, that anecdotal data, we don't have the smoke particle data for that fire. We don't know what the intensity was, and we don't know how quickly it dropped off. Only that in a very short distance, we see differences in the intensity of the effect. So with a rangeland fire that burns up close to your vineyard, it probably doesn't take that long to have an impact. When you start looking at fires that the fires that are quite distant and the smoke has had to travel, our ability to understand that at the moment is fairly limited. That's one of the key things that we will get from this set of experiences. We know what the particle counts were. We can figure out where these fires were and what was burning, and we will have sensory and chemical data for wines made from fruit from these different vineyards. But we won't have that in time to really answer questions for this year.
A question from Brett Eisenhower: does pre-fermentation cold soaking of grapes increase the absorption of smoke taint molecules? I think we touched on that too. Do you want to just?
So doing a cold soak,
Will
So,
that make it worse?
so anything that would potentially lead to greater extraction, for example, of anthocyanins, these compounds, particularly the glycosides of them, probably in terms of extraction behavior are fairly similar to anthocyanins. They have a sugar connected to a phenolic compound that has sort of intermediate polarity. So they're probably going to be extracted similarly to the glycosides will be extracted in a similar way to anthocyanins. The free compounds would be a little bit different, but if you're doing cold soak to improve color or tannin, then you may also be improving the amount of smoke-related compounds that are present in your wine as well. Improving
so
in the
it's
sense
not-
of increasing.
It's not that there's more smoke compounds going into the grapes. It's more release of the glycoside
Yeah.
smoke compounds in the berries because we have this enzymatic berry action going on.
Mhm.
So that's not a good practice when you're worried about smoke. Is there more absorption of taint from fermenting with a percentage of stems added to the fermentation?
I'm not aware that anybody has done that study. It's one that probably should be done. The rachis would absorb these compounds in much the same way that the berries or the leaves would. So I would expect there would be some level of the volatile phenols and maybe their glycosides in the rachis tissue to be released during the fermentation. So it wouldn't surprise me if you added stems back that you would see an increase relative to a fermentation without stems.
Yeah. Here's a question to the Smoke Research Consortium, probably. What is the industry standard, or is there already an industry standard for levels of smoke taint compounds in grapes to decline to pick the grapes? I think that's still under discussion, right?
Yeah,
Tom, do you want to take that, or?
There's not an industry-wide standard yet, and it's related to some of the things we've already talked about. We don't necessarily know in any, because there's not only the amount of these compounds that present that results in the outcome, it also is affected by the matrix they're in. And so from wine to wine, the level it takes to create a problem is likely going to be different. And so setting a definitive standard is going to be a difficult thing to do. I think there are some contracts out there that have levels established, but I don't think there's not yet an industry standard. Maybe Vicky or Melissa might have some thoughts on that as well.
No, and I think the challenge, thanks, Tom, in listening to many conversations up and down the West Coast, the challenge becomes that we don't have a baseline for a lot of varieties and a lot of types of smoke or length of smoke or type of. So it's really hard to have a standard when you really haven't set where we're starting from, which is one of the benefits of you and Anita and Elizabeth working with USDA ARS, is helping to start to develop those.
Yep.
Then eventually maybe we can, but I think we're a ways from that, which really emphasizes the need and the concept for shared responsibility, because there's so much we don't know. So the partnership between grower and vintner is really important right now. So I really appreciate you weighing in to help both sides of this equation get to the bottom of these answers, or at least as close as we can get.
Yeah, thank you, Vicky.
That actually reminds me of one other thing I meant to say about bucket fermentations. There's an opportunity there for growers and winemakers, I think, in many cases, should be trying to taste those bucket fermentation outcomes together, so that there's an opportunity to both maybe get a better understanding of what's actually going on with in some of these cases.
Yeah, thanks. Roger Gamache asks, are there methods to mitigate the exposure in the vineyard? I think he's asking, are there materials you could apply as a protective barrier so that the smoke taint compounds do not enter the fruit?
So the concept of barrier sprays is an active area of research in this, in smoke exposure. We have done some work here over the last 2 or 3 years, and one of our trials this year was a barrier spray trial, and the additional smoke exposure we were planning to do this year was actually to do a barrier spray trial with some additional material. I'm not sure yet whether we're going to go forward with that for this year or not. We do have one trial that we sprayed vines with kaolin, which has been tried a few different times in different locations. Bentonite is another one that we have used. The first year we did this was 2018, and the outcome then was inconclusive. Bentonite didn't seem to make it better or worse. Kaolin appeared to make it slightly worse. In 2019, we repeated the study, and in that case, with some differences in how we applied the material and when, we saw reductions in the amount of glycol and 4-methyl-glycol in skin extracts from sprayed fruit that was sprayed with either material versus the unsprayed smoked control. We're repeating that again this year because it's, you know, it's a vineyard trial, and it's things that we want to look at repeatedly to try and understand better what are the factors. We think coverage and the extent of coverage is important. There may be a timing component of it. The good news, I suppose, is those barrier sprays are still in place in those vineyards, or in those, you know, on the vines that we sprayed. And if you, I mean, I was out there a couple of days ago, and the kaolin sprayed ones still look white, so there's still kaolin there. So we'll have a double exposure test of those two materials for this year.
But it's a reduction, not an elimination. It's not a complete protection.
It is a reduction. There are some other materials. There are the group at University of British Columbia published results looking at parka. It's a material that I think normally is applied to cherries, but was used as a potential barrier spray in one of their studies. They found that it worked. The outcome in some other studies with that material is less clear. There was also some, in our discussions with our colleagues at AWRI, they expressed some concern about the potential for spreader sticker type materials in sprays having the potential to make things a little bit worse as well. So we haven't looked at those materials yet, but I think it's worth pursuing, particularly if there's an instance where there's something that actually not only doesn't help, but has the potential to make it worse.
Got quite a few more questions, so I want to make this quick.
Have to give quicker answers.
Yeah. Kenton Irwin asked a really good question here. Have the Washington State University, the Washington State Wine Commission, and maybe the Washington Winegrowers started a communication with forest management agencies to do controlled burns that would reduce the risk of large fires. And connected with that, we don't want fires at the critical time for grape growers, have those fires in a part of the year when we don't get damage to the grapes. Vicky, Melissa?
Well, go ahead, Melissa. I'll come after.
Yeah, well, that's subject for a whole nother webinar, but I know in Australia, the concern was controlled burns making it worse for grapes. And that is something that Tom and I talked to USDA in 2016, 2017, back in DC was, you know, at some point we do need to work with the Forest Service, because if they make these controlled burns, as Thomas just said, we don't want them to come at the wrong time.
Yeah.
But as far as, you know, the wine industry being the leader to try to minimize forest fires, I think that's a way bigger bite than we have.
Yeah, it's a way bigger bite. And from a public policy perspective, I think what we can do, and the part that we can control, is continuing to reach out to the policymakers at both the state and federal level in ensuring that they understand the needs of the industry, because honestly, there's decisions made that there's not a general understanding of production agriculture, maybe at all, and certainly of the nuances that the wine grape industry has. So we can't change. We don't have the size nor the weight nor the funds to be able to alter that decision-making process. Many parties have been trying for many years to do that. We can stand up and share why it impacts us, and that they need to be cautious and careful and considerate of what's happening in production agriculture.
Yeah, and I know we're pressed for time, but one final comment. When we talked to the Forest Service in 2016, they said, you're the first agricultural group that has come to us and expressed any concern about how our practices might be affecting your products or your crops. So they were not aware that the way they were managing things had any impact on us, or any other ag for that matter.
Thank you. So Lee Bartolome asked, how do fresh berry or grape samples correlate to the bucket fermentations? This might be a question or two. How does the tasting of the fruit in the vineyard, how taste of the fresh fruit correlate to the sensory impression in the bucket fermentation?
We have not looked specifically at fruit versus bucket or even wine. So I don't have any real solid information to convey there. It's something that we probably should look at, is how does tasting fruit compare with tasting the bucket fermentations? But it's something we haven't looked at yet.
Yeah, I just know from personal experience, I tasted some fruit in the vineyard that tasted really good to me. And then we analyzed it, and you analyzed it in the lab, Tom, and it was quite tainted. So it's, I think it's a pretty tough thing to distinguish these flavors in fruit. A lot easier in the bucket fermentations.
And to be clear, that was not fruit from this year, because we haven't done any fruit analysis yet.
Thank you, yeah. Dr. Collins, how have these two natural smoke events affected your field trials?
Well, I don't know. I think there's probably pluses and minuses. For the barrier spray program, it's yet another challenge for those materials to see how they'll work. In general, I think the level of smoke, and that's very specifically why one of our particle counters is at the Rosa, is we want to know what the actual exposure is and how that level compares to what we're applying, which is why I had the information to share today about what our levels were. And you can see that the amount we applied, at least in one of those trials, was still significantly larger than the amount of particulate matter that vineyard has experienced as a result of these events. So my expectation is it makes it a little more difficult, because our controls will have some level of smoke, but our treatments are high enough that we'll still be able to see a difference between what's in the controls and what's in the treated wines. Everything got the natural smoke that's occurring now, but the vines we treated are going to be, there's still going to be, I think, a much bigger impact there.
Another question, does it make sense for an individual grower to own a PM1 sensor? And there was a related question, what was the model and make of the sensors that you're using, Tom? I think we can certainly share that information.
We can definitely post that. The company that makes the counters we use, and there's a whole range of them, is TSI. They make all kinds of sensors for all kinds of things, but they do a lot of particulate matter counters. This one is a side pack 520, and it's actually intended, the original intent for it anyways, was you'd carry it on your belt like we used to carry cell phones around, and it would monitor the exposure that you experienced while you were working in an environment with high particulate matter. Does it make sense for an individual? I think at some point, or a single farm or something like that, it may at some point, but they're pretty pricey. Those side pack monitors, the one I showed the picture of, that's, you know, not much bigger than the first cell phones, is $5,200. So they're not cheap. and the more sophisticated ones go up from there. So from my perspective, it may make sense that this is something we work, and I'm not sure who we work with, but maybe this is something that we develop a network. Maybe it goes on ag weather net stations. I don't know, but I think putting together a network for monitoring this is something that we should be looking at.
We do need a network that has a lot more monitors, and this is actually the next question. Is there potential to partner with Ag WeatherNet? Yes, the potential is there. We'll have to figure out how to purchase additional monitors and maintain them, but that's a good idea that might be integrated into Ag WeatherNet.
So the other thing that's important to note is when we look at AQI and these PM 2.5 monitors, those are generally located in towns, not in ag areas. They're not in rural areas. They're in Yakima and they're in Kennewick and they're in Sunnyside. They're not necessarily in Vineyard or other rural locations.
A question, how does fire temperature impact the severity of the smoke effects?
We don't know specifically how it affects the severity of the effect. We do know that the hotter the fire, that hotter fires produce different smoke than smoldering fires, and that so many of the things that we're concerned about, guaiacol, 4-methyl guaiacol, syringol, are thermal degradation products from heating lignin, which is the polymer that gives woody material its strength. And the hotter the fire, the more complete that degradation is. And so in a really hot fire, you may actually see less guaiacol and other things because the initial step in degradation of lignin produces the guaiacols and things that we're concerned about. But if the fire is hot enough, they'll continue to be degraded to smaller organic compounds that won't have those smoky aromas. So hotter fires are probably less impactful than cooler fires.
Something we haven't been able to touch on much is the question, what is the current understanding regarding the absorption of these smoke-taint compounds through the berry skin versus translocation through leaves, grapevine leaves?
So we know from work that was done in Australia in probably 2008 and 2009, that translocation is possible. So they put marked compounds on leaves and looked for the marked compounds in the fruit and found them. So we know it can happen, but in general, that's not the major route. So the major route is direct absorption through the berry skin. So what's in the berries comes from stuff interacting with the berry surface with limited translocation from other parts of the vine. That's where we're at now. And I think that's reasonable.
And then the next two questions from Darren Garrett. Unfortunately, we cannot yet simulate the effect that distance has, the distance from the fire to the extent of smoke taint that might happen. We're not set up to do that either in the hoop houses nor in atmospheric larger scale trials.
Yeah, we're not set up to do that now, which is why it's important when we have an actual event where the smoke has traveled some distance that we, for better or worse, make the most of it and collect the data and look at the outcome. It's difficult to put together a protocol that we would generate smoke and probably not be able to hold it for some period of time and then put it on the vines. More likely we would generate the smoke, run it through some kind of reaction chamber to simulate the effects of sunlight and other reactions in the atmosphere, and then put it on the vines, but we're not there yet.
Yeah. Quick question, do you have any monitors at this time in Walla Walla?
We don't have, our monitors are in the Yakima Valley. We have one down near Patterson, which is probably the closest one to Walla Walla, and then one up towards Mattawa.
Yeah. I think you answered this one. What was the sensory evaluation for the bucket fermentations? I think that was done. Is that correct?
For the trial we did last year, yes, we did do sensory evaluation of the bucket fermentations, and the results correlated well with the chemical results, including the notion that Grenache was somehow different because of the importance of Cresol to that. And we saw the panelists in that descriptive analysis found that there were some sensory differences between Grenache and the other varieties in terms of the character of the smoke, the character of the smoky flavors and aromas.
Greg Lipster is asking, okay, how much more time do we have, Melissa?
Minus 3 minutes.
Yeah.
Yeah, I think Aaron, who's still on, has not cut us off yet, but if we don't get to, and I see our numbers are starting to drop off, but
Yeah.
if we don't get to all the questions, perhaps there's a way that we can type them up and include them
I think
somehow
we'll
when
have
we
to-
send the link out.
We'll have to do that, yeah.
And some of these, I think, are also, some of the questions we've already talked about are also addressed on the frequently asked questions sheets that will come out from the task force in the next few days.
Right, right.
So I think we'll have to leave it at that, right? We'll summarize the last questions we haven't been able to answer here in this conversation. And we can send that out with that frequently asked questions list.
Yep.
Well, then,
Sounds good.
well, we'll thank Tom Collins for hanging in there and giving us all this recent update and for this great research that we're conducting here. Thank you, Tom, and thank you, the Wine Commission and the Washington Wine Grape Growers for the support to make this all happen.
And thanks to everyone who helped pull this together and make this possible this afternoon.
So Tom, I saw in the Q&A, I think this is kind of the overriding question, you know, what is everything, the data you've collected, what does it mean? And in short, you can't tell somebody right now they do or don't have a problem, correct?
We can't, yeah, we're not at the point that we can look at this particle data and tell you whether you have a problem or not. We will have better understanding, not only for this season, what's happened, but better ability to look at this going forward based on the outcomes of connecting the particle data that we've collected with the chemical and sensory evaluation of the wines that we'll make from the fruit where we know what the exposure was. So I mean, it's an important step in getting to the ability to look at an event like this and say, you need to be concerned or not, but we're not there yet. Anything I could say right now would be speculation, and I don't think we want to do that.
So do your bucket fermentations.
Do your bucket fermentations. Smell and taste your wine. Involve everybody you can in the process. Because one of the other things is a certain number of people who just don't get smoke taint, they don't perceive it. And so you need to have multiple people involved in evaluating these wines so that you get a broader perspective of what the intensity might be if it's there.
The good thing about perceiving the smoke taint is when you taste it, it's ugly. You don't have to find words for it. We can tell on your face that you did. So that's certainly true, but then our sensitivity varies, of course, tremendously from person to person.
Yep.
Thank you, Melissa.
All right, thanks everyone.
Okay, yeah, I think that, and thank you, Aaron, so much for pulling this together. Aaron Brumbaugh from Tri-Cities WSU. He's going to be sharing a link with Vicki and I tomorrow morning or sometime tomorrow, and we will, all the registered participants would receive it, as well as we'll send it to our normal list. So thank you, Vicki. Do you have anything else to add?
Thanks, everyone.